Today we'll be discussing reference angles in trigonometry on the coordinate plane and how to use them in conjunction with common trig values and some substitutions for working with trigonometry. So the definition of a reference angle is the acute measurement from an angle's terminal ray to the x-axis. Now, this is different than an angle in standard position because we are just measuring from the terminal ray to the x-axis so that we've got an acute measurement, something less than 90 degrees or less than pi over 2 radians. So, for example, if I have my coordinate plane and I have my initial ray here and a terminal ray here, and I have designated this particular rotation to be the angle theta, and mark that as theta, then the reference angle would be this distance from the terminal ray to the x-axis, and we would designate it as theta sub r, as in the reference angle. And we do that because then we can take that reference angle, that acute measurement, and that's kind of the key in here. We can take that acute measurement and treat it like a first quadrant angle, which is really nice because we know a lot of stuff about first quadrant angles. We know sine of 30 degrees, we know cosine of 30 degrees, tangent of 30 degrees. We might not know that one quite as well. We know sine of 45 degrees, cosine of 45 degrees. We know tangent of 45 degrees, sine of 60 degrees, cosine of 60 degrees, and tangent of 60 degrees. You might want to take a moment, pause the video, and see if you can fill those in. I would say, however, that tangent of 30 degrees and tangent of 60 degrees are a little less important. But the other 1, 2, 3, 4, 5, 6, 7 values on there, you really should know those. They're what we call the common trig values. But we'll be able to use these in conjunction with our reference angles to go ahead and do that. And we can do this in degrees or radians, and mostly we're just going to be doing some simple arithmetic subtractions from those x-axes. So let's look at a couple of examples. So if I had a theta measurement of, I don't know, 342 degrees, and I wanted to figure out what is the reference angle for that theta, what I could do is I could draw this on my coordinate plane with my initial ray and my terminal ray, and I should put the arc on there to designate that it's a positive angle rotated counterclockwise direction, less than 1 revolution. The reference angle would be this measurement right here, theta sub r. So in that particular case, my calculation, I would say that if I took 360 degrees and I subtracted from it 342 degrees, I am going to get a measurement of 18 degrees. Let's see, 42, 52, good, yeah, 18 degrees. So in this particular case, theta sub r is going to be 18 degrees. And I just do some subtraction. Generally, when I'm measuring off of the positive x-axis, I can do additions and subtractions from 360 degrees or 2 pi radians. When I am measuring off of the negative portion of the x-axis, I would be adding and subtracting from either 180 degrees if I'm using degrees or pi radians if we are working with pi radians. So that's one example there. Let's do another example with radian measure. So let's say we had theta equals, I don't know, if we had theta equals, I don't know, 9 pi over 10 radians. And we wanted to know what is the reference angle for 9 pi over 10 radians. Well, I'd have to have a sense of how big 9 pi over 10 radians is in standard position. I draw my initial ray. Now I look at that 9 pi over 10. I suppose one way of thinking about that 9 pi over 10 is that I could split up the 9 pi from the 10 and make it 9/10 pi. And I see that as being, that 9/10 is just a little less than 1. So that's a little less than 1. So it's a little less than 1 pi radians. So I know I'm going to have a second quadrant angle, that sort of rotation to get that. And my reference angle will be the measurement, the acute measurement from the terminal ray to the x-axis. So I'm looking for that distance there. Well, I know if I had gotten all the way to this negative piece of the x-axis, had my terminal ray gotten all the way to there, then I would have a measurement of pi radians. But I didn't get all the way there. I only covered 9/10 pi radians, so I'll subtract, and I see that I'm 1/10 pi short. Or conversely, you could say that 9/10 pi plus 1/10 pi radians is pi radians, to complete the semicircle there. Either way, the reference angle for 9 pi over 10 radians is 1 pi over 10 radians, or just simply pi over 10 radians. Let's do 2 more examples. I'll set it up. I will give you you should probably pause the video, try to do it yourself, and then see the solution that goes with it. So if I set up a theta of negative 167 degrees, what is the reference angle? So what you could do is, what you should do is draw the coordinate plane, draw negative 167 degrees in standard position, and then you can measure your reference angle, do a little addition or subtraction or so on and so forth to get your value there. So why don't you pause the video, try it yourself, and come back in a minute. All right, so hopefully you tried that yourself. Draw a coordinate plane. Draw my angle in standard position. It's going to have a negative rotation. And I am looking for this measurement right here. This is going to be my reference angle. If I ignore the signs and the rotations, the direction of the rotation, I know that the absolute values of the theta and the theta sub r should add up to 180 degrees. So I can say 180 degrees minus 167 degrees is going to be equal to 13 degrees. So that measurement there, that theta sub r, is going to be 13 degrees. And I don't have to worry about negative. I always want an acute angle. I want it to be positive. Eventually, we're going to start reflecting this into the first quadrant. So I always want those to be positive. We'll always take the absolute values. All right. Let's do an example with radians for you to try on your own. So let's add a theta equals, I don't know, 17 pi over 3 radians. And I want to know what is the reference angle for 17 pi over 3 radians. Once again, draw your coordinate plane, draw the angle in standard position, and then measure the acute distance to the x-axis. So go ahead, pause the video, try it yourself, come back for the solution. Okay, we're back. Coordinate plane, standard position. Now 17 pi over 3, that's pretty big. I might want to maybe think about this as a mixed number, 17 pi over 3. The 17/3 part of this is really equal to 5 2/3. So it's 5 2/3 pi radians. So what I'm going to do is I'm going to actually draw my circle first, the arc that goes along here. So there's, well, let me change my color here. There's 1 pi radians, 2 pi radians, 3 pi radians, 4 pi radians, 5 pi radians, 5.5 pi radians. Every quarter of a revolution is pi over 2 radians. Now, and 2/3 is a little more than a half, so I'll kind of go to here, and I'm going to draw my terminal ray there, put a little arrow on the arc, and that is an angle of 17 pi over 3 radians. My reference angle will be this distance right here. What I could say to figure this out is I know that I went 5 2/3 radians. Had I finished, and I'll do this with a dotted line, had I finished to there and finished that full revolution, I would have been at 6 pi radians. But I'm a little short of it. How short of it am I? Well, that'd be 6 pi minus 17/3 pi. That's my 5 2/3 pi radians. To figure out how, like, what is that little purple distance there? So that'll be 18 pi, sorry, 18 pi over 3 minus 17 pi over 3 equals 1 pi over 3. So that distance right there, that reference angle is going to be pi over 3 radians. Okay, so those are just a few examples of what a reference angle is and how to find them. We have not discussed what to do with them yet and why they are helpful. That'll come up in the next couple of videos that we make. This was just the introduction to what they are and how to find them. Thanks for watching.